Hey folks, welcome back to the bench. So as you can see on here, I have a rather large Fender bass amp. It's kind of blocking all my light, so you can't see it too well. I'll get up on it here. This is a Fender model Sidekick 35 bass amp. So it's a single channel amp, but it has dual inputs, little peak indicator. So it has a gain, which is kind of like your preamp level. You got treble tone control, middle tone control, bass tone control, and a master volume. This frequency thing here, not really sure what it does. Typically these will be a sweepable mid, but if it was a sweepable mid, I would think it would have the frequencies on the dial instead of a 0 to 10. So again, not really sure what that does. We'll figure that out later. Yeah, master volume, I think I said that already. This is a limiter switch. Not really sure what it does, but I'm assuming if you put it on, it'll cause this thing to basically flatten out or limit the signal that goes in so that you don't kill the speaker or the rest of the amp section. And you get your power switch up front. So my buddy dropped this off to me, and I've worked on some of his other stuff. He's got some really high-end amps that I've done some work on, quite a variety of stuff, but he really loves this little thing, and he loves the tone on it. Would dearly like for me to bring this back to life. So you know what? It's here. Let's see if we can fix this and get this thing going. All right, stay tuned. Okay, so we're at the back side of this thing, and as you can see, it's a sealed speaker cabinet and not an open back style, and that's pretty typical for bass amps. I'm not sure if it's ported up in the front or not. We'll have to see that once I get the grill off. I haven't done that, but let's take a look at the back here. Some of the controls now, because it's sort of dark, I got a flashlight here to kind of help us out. So by evidenced by these heat sinks back here, obviously this is a solid state device. So there are no tubes in this amplifier. So there's our mains transformer, and we have a primary fuse, and we got a speaker fuse to protect the speaker. This is your speaker output, 35 watt output it looks like. Nice little Fender plug on there. And then here you've got a preamp output, so that's going to allow you to take the output directly from the preamp, bypassing the amplifier that's built into this thing, and driving another power amp with a separate speaker, in case you can't quite get enough volume out of this thing when you're playing live at the stadium in front of thousands of screaming fans. Let's see, this power amp input, not really sure what that's about. I guess you can take the output from another power amp and stick it into there and maybe drive this speaker with it. I don't know, that's kind of strange, but yeah, so those are the connections in the back here, and we've got Fender Musical Instrument Company, Brea, California. Hey, that's my alma mater. I went to school there. Graduated from there, so that's pretty cool. Got a little piece of my alma mater history. Now, if you look at these connectors, they're looking pretty crusty. Like I said, there's been some evidence that this thing has been out in the elements, and I think my friend had told me that this thing was sitting in a field for a while. Man, I don't know. I'm actually kind of surprised it worked at all. So what do you want to do with this thing? What do you think we ought to do? Think we ought to rip this thing out and then look inside it and check it out? I don't know. Now, you know what I'm going to do actually is I'm going to take these, let's check these fuses, okay? Let's check for two things. One, to make sure that the fuses are good, and two, to make sure that they're the proper size. So, yeah, let's go ahead and do that. And we'll get... All right, this is lovely. Can you see what's happening here? The entire fuse holder body is rotating around inside of there, so that's kind of loose. Not good. All right, I'm gonna have to go commando on this thing, so I'm gonna put the camera down and see if I can get these fuses up. I'll be back momentarily. And here are two fuses that are successfully removed. So this one I actually had to grab the fuse body with a pair of needle nose pliers, and I was able to twist that thing out, and so that was no problem. This one actually has a screw head on it. It came right out because the body was not turning around inside the chassis like this one was. So both these fuses are good. They're both the same, with the same ratings, 250 volt by 2 amp and another 250 volt by 2 amp. This is actually supposed to be a 2.5 according to the outside of the chassis, so that tells me somebody's been in here and has changed these and just used the same fuse for both positions, which is fine. It's always better to underrate a fuse than it is to overrate a fuse. But another problem I noticed is that these are short fuses, and I don't mean that they're ill-tempered. See what I did there? Short fuse, ill-tempered, yuckity yuck. Anyway, They're physically too short. They should come out to about right here where my chopstick is at. And so the wrong fuses were put in. And not only that, when I pulled out the one for the mains, it actually looked like this. It was compact inside of the fuse holder top. There's supposed to be a spring up here that keeps this pushed out and keeps tension against this other side. That spring is missing. So whoever changed these last time lost that spring. So here's what I'm going to do. I'm going to find a spring to put inside of this one. I'm going to put the correct size fuses in here. And I'm going to put them back in, and we'll see if the amplifier then powers up. So stay tuned. Well, as it turns out, the fuse holder for the speaker actually had the wrong size fuse in it, which is this one, so that's a proper size. But the main fuse holder had the right size. It's supposed to take one of these little ones. And so what I did, I couldn't find a spring in my boneyard, so I just took one out of a pen and I cut it off a little bit short. And I'm going to load that inside the gap. We'll put this fuse in there and see where that gets us. All right, here we go, folks. The moment of truth. I got the fuse installed. I got this thing hooked up to my current soak over here. So let's flick the switch. Ready? And a whole lot of nothing. All right. So it's going to be a little more than just a fuse. And that's fine. I'm good with it because I like working on stuff. So we're going to get into this thing. So the next step is going to be removing this chassis from the speaker box and having a look inside. Maybe one of the wires popped off from the fuse holder because it got twisted around a whole bunch of times. Or maybe it's something a little more complicated. Either way, we're going to tear into this thing and have a look. But actually, before I do that, let's see if we can get this front grill out. Take a look at the speaker. Oh, yeah. That's nice. Okay, so that's a pretty good size speaker. It is ported like I thought it might be. But the speaker appears to be in very good shape. So we got no problem there. All right, so let's crack on to get this thing out of the box and have a look at it up here on the bench. And it should be a pretty simple excavation. We got 4 screws. I'm going to remove this guy, and these 2 guys here. I'm going to turn this thing on its side when I remove them so that the chassis doesn't drop out, and then we'll just either slide it out the front or out the back and be ready to go. So this is why you never leave the window open in a car in the garage when you're working on it. Looks like Leo found himself a new place to play. All right, get out of there. Go on. Get on out. Good boy. I have to shut that window. Okay, so I removed the 4 screws and I've got the amp chassis out on the bench. It was really easy to remove. It pulled the 4 screws out, things slid right out. No problem at all. And I'll tell you, most of the weight for this this amp is all in the speaker cabinet because this chassis is extremely light and it came out super easy. And what do we got here? All right, can we focus? There we go. And it looks like it was inspected on January 16th, 1987, a little bit ago there. And it was inspected by Ken. So thank you very much, Ken, for your job well done, making sure we get a quality product that was sent out off of the line. Moment of silence for Ken. Okay, we're done. Let's flip this thing over. Let's see what the inside has in store for us. Here's your front panel. And there you go. Not a whole lot going on. It's a pretty simple amplifier. You've got your mains transformer. Steps down your 120 volt AC to a more manageable AC voltage. You've got your bridge rectifier here, which is responsible for converting the AC into rectified DC, which has a little bit of ripple in it, and then these 2 capacitors are what smooths those out. And then as we move along, you can see we've got our output section here as evidenced by this big heatsink. So these are your 2 output transistors. This is your driver. I'm going to assume that this is more than likely the preamp, this op amp right here. And then these other transistors might be for some tone controls or some other effects and things like that. And then you have your control board that's up here, and that's about it. It's incredibly simple. So what I'm going to do is plug this thing in and make sure it's on the current soak, of course. And I start checking voltages and make sure I have it coming out of the mains, out the hot line here, coming through the other side of the fuse, and then from there it goes to the power switch. And power switch is hooked up to one side of the transformer. The other side of the transformer goes back through the neutral, back to the power switch. And then you've got the, it's not power switch, I'm sorry, back to the outlet. Then you got your chassis ground protection, and then your AC output of the transformer is hooked up here, rectified, filtered, further signal processing here, and it goes out here to your controls, and then ultimately out through one of these two jacks right here. So that's what I'm going to do. I'm going to take the voltages. Unfortunately, I'm filming this thing while I'm holding a phone, so I can't do the troubleshooting live. So I'll check some of the voltages out, and I'll come back and let you know what I find. All right, so I've finished my preliminary inspection, and so we've got the neutral wire right here, which is soldered to this post, which also goes to one side of the transformer input. We have the other side of the transformer input coming from first here, goes through the fuse to the switch. When you turn on the switch, it shorts out these two lines, and the voltage goes to this yellow wire, which is the other input of the transformer. Okay, I have 120 volts going into the transformer, and the switch is functioning properly. However, I have no output at all on these three lines. So it would appear to me that this transformer right here is defective. So I'm going to have to pull this out and look up the specs and see if I can order another transformer to put in here. It shouldn't be too expensive because this is not a real high-powered instrument, and this transformer is actually probably pretty common. I might actually be able to steal it out of another piece of equipment I've got laying around here. So I'm going to go ahead and proceed to do that, and I'll be back when it's installed and finished, and we'll continue our troubleshooting on this amp. The transformer has been successfully excavated from the unit and freed from its life in there. Not a lot of heft to this thing. It's not a real big transformer. This amplifier is only 35 watts, so it doesn't require a whole lot of iron to power it up. So, what was wrong with this? Well, I did a preliminary test inside the unit. When I took the transformer out, I did a further test. So, you have your primary winding on the transformer, which goes to the plug that plugs into the wall in your house. So your 120 volts is applied here. You have the secondary winding of the transformer, where the lower AC voltage is then applied to the circuit, rectified to DC, filtered, and regulated, and sent to different areas of the circuit to do its job. So when I say winding, transformer windings, it's basically a big coil of wire. So physically inside of this transformer, these two wires are connected to each other. It's one big long string of wire put in a coil, and the same with the secondary winding. But the two windings don't touch each other. So if you put a voltage here, an AC voltage here, it gets induced onto this secondary winding. And depending on the windings ratio, you're either going to have a higher voltage here or you're going to have a lower voltage here. This particular transformer wants to take the 120 volts from the wall circuit, and it wants to reduce that amount of voltage to something a little bit more usable. So we can rectify it and use it on the circuit side. And that's basically what that is doing. So when I tested this, these two primary wires, which, like I mentioned, were one coil, should measure a very low resistance and show that they're connected. When I measured them, it measured as an open circuit. There was infinite resistance between these two wires, which tells me that this primary winding has failed in some way. It's either opened up on its own because of physical problem or some kind of quality workmanship, or it has been burned up. Check the secondary side was fine. So what could cause this? Okay, so like I said, could just be an issue with this transformer. Could have just burned up because it's a low quality transformer. That's very possible. Another thing could have been, we could have got some surge current or surge voltage from the AC line that this was plugged into at one point. And if this mains fuse was overrated, then it's going to burn up the transformer before it pops this fuse. And I'm thinking that's a pretty good possibility, because when I got this in, both of these fuses had been changed. One was right, one was wrong. And so I don't know the history of this amp. At some point, somebody could have stuck a 15 amp fuse in here, just not knowing what happened because the other fuse had burned out, and that could have burned up this transformer. So again, don't really know, but what I do know is this does need to be replaced. So I did a little pick and shovel work on the internet and found that this transformer, so for the 120 volt input, this is a center tapped transformer. So we have these two red wires, which are the secondary coil, and then in the middle it is tapped with this black wire. So this black wire can be used as a reference. So if we measure AC voltage from here to here, we should see somewhere around 44 volts AC. If we use the center tap as a reference, if we measure, sorry, from oh man, I'm getting ahead of myself here. If we measure with the center tap as a reference, so from center tap to one side, it's going to split the AC voltage in half. So we'll see 22 here, and we'll see 22 here if we use this as a reference. Okay, enough of the transformer lesson. So I need to find one of these. This is rated at about 2 amps. So I will look for something in a similar physical size, but I'm more concerned with the actual ratings of the transformer. If the physical size is a little bit different, it shouldn't be too hard to adapt to this chassis, because you've got this bracket here that's pretty thin metal that can be modified. This could be cut, or even, you know, if the transformer is physically smaller, I may be able to just mount it directly inside of this chassis and figure out some way to make it work. But I'll cross that bridge when I come to it. So I'm going to go search around, see if I can find a transformer that's going to work in this thing, and we'll go from there. So I got the new transformer in. It's like Christmas here. As you can see it, new one, old one, kind of obvious. This one's nice and shiny. I bought this through, I want to say Amplified Parts, I think it was. It's a Hammond transformer, so it's pretty high quality stuff. And so it shouldn't fail like this original one did. Now, if you look at them, they're similar in size and construction. The only real difference is this has a different external bracket on it. And also your primary and secondary wires come out on opposite sides of the bobbin, where this particular one doesn't have a bracket on it. It's got this little cover that was kind of taped on there. And you'll notice that the primary and the secondary wires come out the same side of the bobbin. So what I'll do is I'm going to take this metal bracket off of here. And then once it's off, I'll remove the cover from this one. And I will place it on this one in the same way. And what they have is this, they got this nice little hole right here in the iron core, and I can feed these two primary wires through that hole to come out the other side, so that all the wires exit on the same side, and I can mount this the same way it was and install it the same way it was. So that should be pretty cool. All right, so I'm going to do that. And this is the old bracket that came off, and it'll go on this, and it'll mount, and no one will be the wiser. So while I'm in there, too, I was waiting for it. I took this main board off, and there's one, there's another standoff, and there's another one back here. And I removed it from the standoffs because I wanted to take a look at these connectors right here, your outputs and your input. Because the only physical connection they really have are the screw terminals that go to the back, and also they're hanging on the board by the solder. And what that causes is a lot of times you'll see stress fractures on these types of things. I'm trying to get this thing to focus right now. There we go. You see that ridge, that kind of dull ridge, sort of looks like it's cracked there? That's a stress fracture, and there's another one here, and this one as well. These two don't look too bad, but it's just a matter of time before they go. So what I'm going to do is I'm going to remove the solder from these. I'm going to put some flux on there to clean them up, and I'm going to resolder and make sure that they're good and strong. I'm also going to go through here and check some of these other points, some of the larger components, the components that get hot and cold and go through thermal cycling, and make sure I don't have any stress fractures there as well. And once I do that, I will replace this heatsink grease on the back of the output components. If I flip it up here, you'll see that's where those are located. Those are what generate most of the heat, so they got this big heatsink on here. So I'll replace that grease, and I'll remount it to here. And that'll be all set. Another thing I'm going to do is if you look at these, this is where the transformer connects, are these thin little hokey little things. I'm going to cut these off, and I'm going to solder directly into these eyelets, and I think that'll make for a much better connection on this thing. Let's see, let me flip this around, and this control board here houses the tone circuitry, and I think some of the reverb circuitry as well. And it also has the potentiometers, or pots as they're called, for the volume controls. So I'm going to pull these knobs off. I'm going to remove this board. I'm going to clean out each one of these pots with deoxit, and I'm going to check some of the solder connections on this board as well. And once I have everything off, I'm going to give this faceplate a nice little bath, because you can see it's got a fair amount of dirt on it. I'm going to clean that up. I'll clean the knobs up and make sure it's all nice and shiny. And once that's all done, I'll put this thing back together. We'll test it and be good to go. So stick around while I get that done. Okay, quick update so far. I've got the transformer installed. And as you can see, that these are the original holes that the bracket went in. I actually had to scoot the transformer up a little bit this way, so I could align this hole so that the primary transformer wires could come through the bottom. So I had to re-drill and tap these holes and put the bracket in. It was no big deal. It didn't take a whole lot of time. So I've got it all wired into the main AC circuit on the primary. So you can see here from the cord, so the cord is right here, big beefy cord, little tiny wires. So you've got the hot line coming in right here, which goes to the fuse holder right here, and it comes outside the fuse holder, goes over this way to the switch, and the other side of the switch is soldered to one wire of the transformer primary. The other transformer primary wire that you see, if I move this white one, coming right here, kind of curves around, and it goes on the same terminal strip that the neutral wire for the AC cord goes to, and it goes back to the neutral wire. So that's our complete circuit for the primary side of the transformer. I've not hooked up the secondaries yet because I'm working on this board. So like I said, I desoldered all the old stuff off of here. I put some new solder on these and cleaned them up real nice. I also found some other cold solder down here towards this end of the board on some of these devices and some other things. So, you know, there's a couple of things that can cause that. Before I talked about stress fractures, I also talked about thermal cycling. Also, if the component legs are not heated up well enough, or you don't use a hot enough iron, a lot of times you can get cold solder as well. And I think that may be what happened to these. When they went through the flow solder process, these are much larger terminals, and it probably just didn't get hot enough to make a good bond. But anyway, those are all fixed up. So I'm going to go ahead and put that heatsink compound back on this. I'm going to mount this board back up. I'll wire up the secondaries, and we'll test it real quick just to make sure everything works. And then I'll get to this control board, clean these pots out, and do all the other stuff I said I was going to do. So that's my update. I'll see you when I get to the next stage. Got it all back together. I got the primary soldered in. I cleaned up all the stuff in the back, and I got the main board hooked up. So let's fire it up and see if it works at this point. So I have it plugged into my current soak. It's currently in production mode, so if this thing draws a ton of current, instead of popping a fuse or burning up this new transformer, that light's going to glow pretty intensely if it's drawing a whole bunch of current. So let's see if it'll go. And oh yeah, see, we got the bright light there. So there's something else wrong with this thing. It comes on, I can see the pilot light lit, but there's a whole bunch of current being drawn when I switch this thing on. So something else is shorted down in the circuit. So let's going to check this bridge rectifier. I'll check these two caps. Those are probably the likely culprits of what's causing this problem. But yeah, let's take this all back apart, which doesn't take much. I just got to unscrew these three jacks in the back, take up these little standoffs, and remove two screws in that heatsink, and I can flip this board back over, start checking a few components. So let's carry on here. Okay, check the bridge rectifier and the filter caps, and they were all fine. So next thing I usually suspect on these little amps, especially with that kind of current draw, will be the output transistors. And so those were mounted here. I desoldered 1, 2, and a driver in the middle, and I pulled the heatsink off. And so here you go. Here's the component. So I want to check these out with my transistor checker and see if we got any shorts in this section. So let me get the little legs turned upside down here, and sorry for the restless video here. I want to get everything in the shot. Okay. I got one here. And we'll get number 3 hooked up here. Okay. Sorry, that's a little cluttered. All right. First transistor, here we go. Okay, so that one checks okay. Looks like it's an NPN transistor. It's got a gain of about 108. And it's identified, base collector emitter. Everything looks good there. Let's move on to the little driver transistor in the middle. And I'm just going to flip these over without me filming myself fumbling. And okay, got a little bit of fumbling on there. All right, so we are now connected to the driver device. Let's check it out. Yeah, there we go. Direct short. Okay, there's one device that's bad. Now let's move on to the next one. This is our output transistor on the other side. So this is a push-pull type of amp. So there we go. That one's hooked up. And let's check that one out. Self-test mode. Yeah, that means it's reading. It's reading like 3 resistors connected together. Some low resistance resistors, and that puts it in self-test mode. So yeah, that one's bad too. So we got a bad driver and we got one bad output transistor. So I'm going to go ahead and replace all 3. So what I'm going to do next is I'll put this thing back together without the output section, and I'll fire it up and see if it still draws the excessive current that it was drawing before, just to make sure that there's no other components prior to this stage that are going to be troublesome for me. So let's go ahead and do that. Okay, we got this plugged back in. I'm back on the current soak in protection mode again, and it's on my Variac. So let's go ahead and flick the power again. So the whole output section has been desoldered and removed completely from the circuit. So if there's any other troublesome parts on here that are drawing a lot of current, we're going to see them over there. So let's fire it up. Okay. And I see no current draw over here. And all the lights are coming on. I go down, get a little slow fade, back up, quick little peak there. Okay, so I'm pretty confident that everything prior to these output transistors and the output section is fine. So I'll go ahead and order those transistors up. Well, first I'll check and see if I got them in stock. I don't think I do. I'll go ahead and order them up. We'll get those replaced and see if we can get this thing going again, finally. It's been a couple days and the parts came in. They got here really quick. I didn't have a chance to really work on this control board and clean up the faceplate because I thought they'd take about a week to get here, but they got here pretty quick this time. So yeah, when I order stuff, I usually order them in lots of 10 or sometimes 20 even if I use them a lot. That's for a couple reasons. One, so I can just keep them in stock and I don't have to wait to order things. Secondly, I can do beta matching on the pairs. Now, this particular unit's only got a single driver transistor, but I use these transistors in hi-fi equipment as well, and many times they're set up in match pairs, so I like to match them up and store them as such. And I do the same thing for the main output devices as well. So, all right, well, let's go ahead and get these old devices off. We'll clean up this board, put some new heatsink compound on there, get them mounted up and installed, and see if they work. Here we go. And also real quick before we get started, just want to mention, I didn't buy the exact replacements because these transistors aren't available anymore. But what I did do is I looked up the data sheets online and I looked up some key parameters for the devices and then I matched those up for some modern replacements. So actually these devices are a little bit overrated for the job that they're going to be in, but of course that's not going to hurt anything. And so just wanted to kind of throw that in there real quick. All right, let's go. Okay, so the old devices are off. I've got all the old heatsink compound wiped off of this heatsink and also the mica insulators. And the mica insulators are there not so much for heat sinking, but just to protect the backside of this device from hitting ground, because this is the actual collector of the transistor, and that's the portion that's going to generate the most heat because that's where the current, most of the current is being drawn from. And so this mica insulator separates the back of this from the heatsink because it has to still dissipate the heat from the back, but you do not want an electrical connection between here and there. Otherwise, the device will short out. And if you look at these screws, you can see these screws also have like a little nylon insulator on the top and to keep the mechanical screw from shorting out against the heatsink, against the, let me turn this over, against the top of the device right here. Other ways that I see this done is sometimes they'll use a screw that's made completely out of nylon and just kind of avoid having this thing on here. I actually like this better because this is a drill and tapped and threaded screw that goes in. It's going to hold tightly, and it's going to cinch it down against the heatsink and make really good thermal contact. So I think that's a better way of doing it. Okay, enough of my babbling on. Let's get these things set and installed. Hey folks, we're back, and here's a quick update on this Sidekick amp. So I got the components here on the heatsink replaced. I put it all back together and fired it up and tried it out, but it appears that without those components in there, we weren't getting a short circuit, but once I put them back in, the circuit went out of balance. We had some more shorts, and so I had to look in there and find additional components that were bad. And right over here is our pile of bad components. Oops, kind of knocked that guy out of the way. So all these have been replaced, and I'll come over here to schematic and show you which ones we replaced specifically. Well, I'll tell you which ones were bad, okay? So initially on the heatsink, Q13 and Q9 were bad on the heatsink. So I replaced Q13, but I also replaced Q12 because these are a matched pair. So I replaced those two, replaced that, put it back on, and I found that also Q11, the driver for the side, and Q7, which is part of the how should I say, discrete op amp circuit, was also shorted. So I replaced these two guys. And then I also replaced Q10 because I replaced Q11, and Q10 and 11 are also should be a matched pair because they're driving Q13 and Q12. And once I did all that, I put it all back together and the circuit worked out fine. I was able to fire up this amp and use it, and it worked great. So, where are we at? I'll tell you where we're at. So once I turned this thing on, I noticed something really strange, and I'll show you right now. So let's go ahead and fire it up. I have my signal generator hooked up to it. I'm putting in a 400 hertz signal, and I'm going to go ahead and turn up the master volume. You can see a nice sine wave there. We'll get it up to the point where it's just about to peak. Okay, right there it's flat topping, so that's peaked, and I'll back it down so that the sine wave cleans up. And so we're looking at about 8 volts, 8 volts AC coming out. So how much power is that? Well, let's calculate it out. So if we want to measure power, we're going to take the output voltage, V squared divided by R. So V squared, 8 times 8, 64. I'm sorry, I used the wrong keys. Okay, let's 8, not 8 plus 8, 8 times itself, 64. We divide that by resistance, which is 8 ohms, and naturally we get 8 watts. This thing's only putting out 8 watts before it starts breaking up. The signal's nice and clean, but it just doesn't have the oomph. It's got about half the power it should. I think this amp is rated anywhere from 18 to 20 watts or something like that. It is probably pretty conservatively rated. So everything is good, but we're only getting about half the power that we need. So what do you think I checked? Well, you're right. I started checking voltages. So if we look at the schematic here, we can see we've got positive 31 volts on the rail, and negative 31 volts on this rail. So we got positive rated, negative, we got a total of about 62 volt swing from negative to positive. So that tells me if I set my voltmeter to DC volts, which it is, I got my terminals measuring from the front, which I do. I've got this guy grounded. So if I check the collector of Q12, right here, I should measure 31 volts. If I check the emitter of Q13, I should be measuring negative 31 volts. Let's see what happens. All right, get my probe in here, and be careful not to touch any of these two legs together. All right, I've got it on the probe. I don't know about you, but I see 14.8 volts or 15 volts. That's about half of what I would expect to see there. Interesting. Wonder what the other side has. Now here's the other side. Let's measure the emitter on that side. There it is. I'm seeing about negative 15 volts, or pretty close to that. So we got about half the power that we need, which would explain why we only have about half of the wattage coming out of the amp. So what was the problem? Well, we'll go back to the source, which is this transformer right here that used to be shorted, and then I went ahead and replaced it. So I misunderstood the transformer markings when I bought it. My bad, but if you look here, it's rated at 22 volts CT, center tap. And here's what I thought that meant. And this is what it usually means, and or maybe I'm mistaken on it, probably am. Anyhow, 22 volt center tap. So here's our center tap line right here. So what I thought that meant is if you're using the center tap as a reference or a ground lead, then you should measure 22 volts AC here and 22 volts AC here. So if you were to measure across these two, then you would see plus 44 volts. Well, that's incorrect. If I measure across these two, I see 22. If I measure with this as a reference to here, I'm only seeing 11. And from here to here, I'm only seeing 11. Half of the voltage that we need. We cut the voltage in half, and we cut the power in half. Pardon me. Wow, that was rude. Okay, so bummer. I need to order a new transformer, which is no big deal. I can use this one in another project. So what I'll do is I'll take this out. I'll order one that has the proper specs. We'll install this and button it all back up and check everything, and it should be fine. What I also did was I cleaned up this faceplate. I had this circuit board out, and I cleaned all the pots and lubed them, and they turned nicely. With everything off, I cleaned this faceplate. I took the knobs off. I soaked them in soapy water and scrubbed them up with a toothbrush. I took my little ghetto polishing wheel right here, and I polished all these nuts that are on the connectors. I also polished the switch, and I polished the metal fittings and stuff on the back. And I also cleaned out these connectors with a brush and some deoxit, and I did the same thing with the back ones. So this thing is ready, and it's working. Just got to replace this transformer so I get the proper power output, and we'll be good to go. So I'm going to order that, and I'll come back as soon as it comes in, and we'll finish up. And just like magic, the new transformer has finally arrived. And you can see it's got the proper rating on it now. 44 volts center tapped. Here's the old one, which is 22 volt center tap. So all I really need to do is take this one out and put this one in. These are the same physical size, even though this one has a higher voltage rating on the secondary. The reason is because this has a lower current rating. This is only rated at 1 amp, this is rated at 2 amps. This particular transformer actually for the current was way overrated than what it needs. So taking this one out and replacing it with this one, we still have plenty of overhead at a 1 amp AC draw according to the specifications on this amp, so we're perfectly fine. So again, I'm going to take this bracket off, and I'm going to take the transformer out and mount it similarly to the way I did this one. I'm going to pull this sticker out and replace it with this sticker. We'll have it all buttoned up and go from there. And just like that, the transformer is replaced. I've got the new one in and the old one out. So here's the new one all soldered up. Got the wires all neatly tied, going to their place of termination. Coming back here, the side's going to the switch, the side's going here, which drops down to the mains, and the mains goes through the fuse into the switch. And we've got the secondaries going where they need to go. So I also have the new label affixed inside of the cabinet so that God forbid if something happens to this transformer again, not that I think it will, but if you put too big a fuse in here like was done last time, and then something shorts out over here, Mr. Transformer is going to go poof like he did last time. But anyway, if it ever does go out again, and I don't know if the guy who works on it, we've got a label right here just saying it's from Hammond Industries. There's a part number, 44 volt center tap. So all this stuff is here. And whoever does work on this next, if it's not me, will appreciate knowing that information, because I had to do quite a bit of pick and shovel work in order to figure out what this transformer was, because it's not written on the schematic, and so I had to do some mathematics and complicated things like that to actually figure out what the rating on this thing was, and I still got it wrong. Hence this guy. Anyway, he's in there, he's installed, everything looks good. So let's say we power this thing up and check it out. All right, we'll flick the switch. Service monitor's on. This time I got a 1 kilohertz tone going in at 200 millivolts. And so I'm making sure that I'm feeding it plenty of signal. So let's check it out here. We'll turn up this volume to 5. We'll turn up this volume to 5. And I'm measuring a little bit of signal there. Now, I increased the amount that the scope will measure because it's actually putting out more power now. So it was getting outside the range of the last settings of the scope, which is why this signal looks so small. So let's get a little more preamp drive there. And let's bring up the master. And there we go. Now we're into massive clipping. So let's bring it down here to where it just stops clicking. Clipping, I mean. Looks good right about there. So it's 15.4 volts AC. Let's see how much power that is. So again, we take 15.4 and we square it, or multiply it by itself, times 15.4. That gives us 237.16, and then we divide that by 8 ohms. And we're looking just shy of 30 watts. Ladies and gentlemen, that's what I wanted to see. These things are rated at about 20 watts to 25 watts peak. We're now doing 29, so that's good. I'm happy with that. Just for fun, let's check and see what voltages that we have at the output devices now. So let me turn this down a little bit, and I get my trusty voltmeter. I've got it grounded to the chassis. I have my voltmeter set up to measure DC volts, and so let's check it out. Let's hit that collector again. There we go. 33.1 volts positive. That's what I want to see. All right, let's check the emitter of this guy here. Negative 33.4. Perfect. That's exactly what I wanted to see. All right. So everything's looking good. Let's go down the front panel here. So if we turn up the gain, and this is the preamp gain, we have a peak indicator here. So if it starts getting distorted from the gain, that peak indicator comes on, and that tells you that you're getting preamp distortion at this point, which in some cases may be desirable if that's the sound that you want. But this lets you know when it's coming in. So with this 200 millivolt input at about 7.5, we're kind of peaking. If I had a lower input, then you'd be able to turn this up higher before the peak kicks in. All right. We've got our treble, middle, bass frequency tones. You have a frequency sweep right here. And here is your master volume. And if you turn your master all the way up, and you start getting your preamp up, that's where you get this massive clipping. That's almost a solid square wave right there. If you kept it like that for a long time, this amp would get really hot. Okay, so let's take a look at this limit switch. What's this limit switch do? Okay, it limits the output to the speaker. So let's see it in action. So we'll put this thing up to clipping again, like that. Turn on the limit switch, bam, cleans it right up. So the limit is on. Now if I turn this down, see the limit light goes off. So as soon as I get to the point where the limiter circuit needs to kick in, it comes on and goes off. And if I go up here and you watch the wave, I'm going to turn up real quick and you'll see how it kind of bounces like that? It clips and then it bounces. Clips and bounces. That's the limit circuit going into action. So if I take it off, ugly square wave. Turn it on, nice pretty sine wave. That's doing its job. And I think that's about it, folks. Got all the bad parts over here. I've got the original bad transformer sitting around here somewhere. And oh, one more thing I want to show you. When we were looking at the back and I was saying, what in the heck is this preamp output and the power amp input? Okay, basically this is an effects loop. So here's your preamp chain. When the signal first comes in, it goes through all the tone controls. A little cut off here because I actually had to blow this up and I left part of that schematic off. But it comes through here, and if you put a plug into here, then you can get the output from the preamp plus all the tone controls and everything like that. You could send this signal level straight to the soundboard if you want, if you're playing at a church or something like that, or you could send it to another power amp. Or if you want to use an effects, then you can loop it out to the effects and then you can loop it back in this way. Because this trail follows here and goes down into the preamp section, and it gets amplified here, and out comes to the speaker. So basically that's all it is. This is a fancy name for an effects loop. That's what it does. All right, folks, I'm going to wrap it up. I'm going to put this thing back in the cabinet. We'll take one more look at it before we end this video, and we'll go from there. All right, folks, well, here it is. It's all finished and put back together, and looks pretty good compared to the shape it was when I came in here. But it's a nice little amp. So I've got it hooked up to my signal generator here, since I don't have a guitar that I can put through it, nor do I actually play guitar, so you wouldn't want to hear it anyway. But yeah, let's put some tones through it. We'll woo. All right. Oh, we can hear that definitely. So let's bring the tone up. Oh, turn down a little bit so it's not so annoying. Sorry, folks, man, I got a cough right now, but don't worry. This is video, so you're not going to catch it. I'm going to step up the frequency a little bit. Okay, so that's about 2,000 hertz or 2 kilohertz. So then we'll take the treble. You hear the boost and the cut. So now let's take it down to something that the mid-range will have some influence on. About 700. A little bit of influence there. If we bring this down, there you go. You can hear the influence there a little bit. Bass, a little bit, not so much. But if we bring the frequency down a little farther, now the bass has a much larger influence on the cut and boost of that frequency. So everything's working good. Okay, I'm just playing now. Anyway. All right, folks. Well, it's all buttoned up. This was fun. I appreciate you all hanging out with me. Thanks for watching, and stop by next time when I got something new to show you. Take care. Bye.